Welcome to Chemistry Chronicles, your favorite podcast where we mix elements of knowledge with a dash of curiosity and a sprinkle of wit. We are going to delve into the intricate world of chemistry and its huge impact on our environment. I'm your host Renata, and today we're embarking on a journey to uncover the chemistry behind one of the most critical environmental challenges of our time, ocean acidification. And today we have the great company of Oscar, who is a marine biologist with expertise in ocean acidification research. Let's begin by defining the fundamental concepts of acids and bases. Acids are substances that are capable of donating protons to another substance, while bases accept protons. Can you explain how the pH scale provides insight into the acidity or basicity of a solution and its significance in aquatic environments?
Certainly. The pH scale, ranging from 0 to 14, measures the concentration of hydrogen ions in a solution. A pH of 7 is taken as neutral, while lower pH values indicate acidity and higher values indicate basicity. In aquatic ecosystems, acids and bases influence chemical reactions, nutrient availability, and the health of marine organisms.
Fascinating. How do acids and bases interact with seawater, and what are the implications for marine life?
Acids and bases can alter the pH of seawater, affecting the equilibrium of carbonate species, crucial for the formation of calcium carbonate shells and skeletons in marine organisms. Ocean acidification, driven by increased atmospheric CO2 levels, reduce carbonate ion concentration, making it more challenging for calcifying organisms such as corals, shellfish, and plankton to build and maintain their structures.
What are the primary drivers of ocean acidification, and how does it manifest in marine ecosystems?
Ocean acidification is primarily driven by the absorption of excess CO2 from the atmosphere by seawater. This process leads to a decrease in seawater pH and carbonate ion concentration. As a result, calcifying organisms experience difficulty in shell and skeleton formation. While acid-sensitive species may face psychological stress and habitat degradation, these changes cascade through marine food webs, impacting biodiversity and ecosystem function.
The implications of ocean acidification are profound. How do these changes reverberate through human societies dependent on marine resources?
Ocean acidification poses significant challenges to fisheries, aquaculture, and coastal communities reliant on marine ecosystems for food security, livelihoods, and cultural heritage. Declines in shellfish populations, coral reef degradation, and disruptions to marine food webs can have far-reaching socioeconomic consequences, particularly in vulnerable coastal regions.
Despite the gravity of the situation, are there solutions to mitigate the impacts of ocean acidification?
Yes, indeed. Addressing ocean acidification requires concerted efforts to reduce CO2 emissions, enhance coastal resilience, and promote sustainable ocean management practices. Chemistry plays a vital role in developing carbon capture technologies, designing climate-resilient materials, and restoring coastal habitats to mitigate the effects of ocean acidification and safeguard marine ecosystems.
It's encouraging to hear that there are pathways forward. How can individuals and communities contribute to these efforts?
Individuals can support initiatives that advocate for climate action, reduce carbon footprints, and promote sustainable seafood choices. Engaging in coastal restoration projects, supporting marine conservation efforts, and raising awareness about our ocean acidification are essential steps towards building a more resilient and sustainable future for our oceans.
As we conclude today's episode of Chemistry Chronicles, we've delved into the complex interplay between acids, bases, and ocean acidification. Through chemistry, we gain insights into the mechanisms driving environmental changes and discover opportunities for innovation and collaboration to address these challenges. Thank you very much, Oscar, for sharing your expertise and insights on this critical issue. And to our listeners, remember that by understanding the chemistry of our world, we empower ourselves to become stewards of a more sustainable future. Feel free to join us next time for another captivating exploration of chemistry's wonders on Chemistry Chronicles. Until then, keep exploring, keep questioning, keep investigating, and keep advocating for a healthier planet. It's now or never.